the last two. But the three things that you need to go away is f prime, dy by dx, and y prime. Those are all names of a derivative of a function.
So should we cut the last two down or should we leave them alone?
It's up to you. It's up to you. Okay, is everybody all right there? Stuart, got it?
Yeah.
Okay. Michelle, got it? Okay. Yeah, the Southern Bells are. So what's the other of a bell? What's the opposite of a bell? You are looking for a southern. Cindy, you are looking for a southern bow. B-E-A-U. Southern bow. Well, shouldn't a bow be the opposite of a bell unless?
Positive, negative, or point girls depends on what way you say opposite.
Oh, that's too deep. I didn't get that. Did you get it?
So the boy version of a bell is a bell, yeah.
That's right. That's what I was trying to get at. The opposite. Hello? So did you find one? Whoa. All right, so you get to do this problem. You need to do this problem, and you need to keep in mind, listen up, okay? You need to keep in mind that last sentence that Medicine just told us, okay? You need to keep that in mind for this problem. You won't need it for part A, but you will need it for part B. All right, you guys with me on this?
This is the slope for the line for this graph, right? And they want you to find the slope of horizontal. So for horizontal line, it's equal to 0. So if this is the slope, you have to make it equal to 0.
So first of all, did everybody get this? Does anybody want me to work this out? Everybody get 2x minus 4? Okay? All right, listen up. Jonathan. Okay, listen up. The second part, it says, use the derivative to determine any points on the graph where the tangent line is horizontal. Medicine, can you give me your last sentence again? Okay, so the derivative is the slope of the tangent. If the tangent is horizontal, then what is the slope? 0. Because remember, this is the derivative at any point on the graph. Right? So then you get x equals from here 2. It wants you to find the point. A point has an x coordinate and a y coordinate. I've got the x coordinate. How do I get the y coordinate? Where? Nice. Take this and shove it in here. And what do you get? What do you get? -1. Okay. All right. What I want you to do is I want you to take your graphing calculator out, graph this beast here. Okay. And then tell me where you think the tangent is going to be horizontal. Okay? And once you kind of visualize that on your graphing calculator, find out the x and y coordinates of that point. Okay, Karthik, I don't know where you are, but I'm waiting for you guys to shut up so I can explain to you the homework problem. The homework problem is not quite like all the intense algebra that I did, okay? But it's perhaps a little bit more tedious work. So read the question, okay? It's number 7 on page 47, okay? So it says, consider the function fx equals 4x minus x squared, and the point P, which is 1, 3. Okay, I'm not expecting you to graph this or anything like that, okay?
You're not expecting us to graph it?
No, I'm not expecting you to graph this necessarily. No, well, Yeah, you can just sketch a graph of that is okay. But I'm going to show you how to really organize the work, okay? You're going to have a table with 3 columns. And it's telling you to pick the points x as 2, 1.5, 0.5. All right? What you're going to do is you're going to take this 2 and shove it in the equation to get the y value. What do you get? What do you get? 4. So your point Q is 2, 4. Okay, for this particular x. What is the slope of the line that joins these 2 points? -1, or is it 1? No, it's positive 1. Yeah, 3 minus 4, 1 minus 2. Positive 1. And then I want you to repeat and fill this table in. So really what's happening graphically is if you want to graph this function, the function looks something like this. What you're trying to do is you're trying to estimate the slope of the line, of the tangent line at this point here. You're trying to estimate that. And what you're doing is you are taking, first of all, the slope of a secant line by getting the point, this line here. Okay, and then this point is moving closer and closer and closer to that guy. Okay, it's moving on this side and from the other side, from both sides. So your slope of your tangent line should be somewhere between whatever answer you get in here. Whatever answer you get there and there. It's got to be in between there. Okay, that's what they're trying to make you explore. Okay, so this is an exploration. It's not an algebra problem like the one that I did. And then number 8 is in a very similar way. Okay, just organize it in a table. Yeah.
For like at what point, like when you find the slope of secant, like that one, you use the equation of like, or the point.
It'll be the same thing. So this point here is going to be 0.5, and you're going to plug in half there, right? So that becomes 2 minus a quarter, which is 1 3/4. So that's 7/4. So your point Q is now 0.5, 7/4. And then all you're doing is finding the slope between these points and that point there. That's all you're doing. Okay? So it's got no algebra like what we did today. It's got no algebra. The kind of algebra that we did today is going to show up later on in chapter 2. Because we're going to come and revisit this in chapter 2. And in chapter 2 on the 27th, 28th, and 29th, we're going to be working in the Career Center on a computer there. Okay? And then we're going to do that on a computer. All right? Okay, I'm done for the day.